In the previous section, we looked at being able to define trigonometric functions in terms of the unit circle. In this video, what we're going to start looking at is how we can define trigonometric functions in terms of right triangles. And so we're going to have four main objectives, is to be able to define the trigonometric functions in terms of any right triangle. Specifically, we're going to take a look at 30, 60, 90, as well as 45, 45, 90 right triangles to evaluate trigonometric functions and angles. And then we're also going to take a look at cofunctions, and we're going to be able to use cofunctions to evaluate trig functions whenever possible. So whenever we take a look at a right triangle, okay, there's going to be two sides, okay, and one side is going to be adjacent to the angle theta. All right, so we're going to take a look at some specific angle. And of course, there's another angle up here, which we might call like beta or something like that. And we could do the same thing with beta, but let's just focus on theta in this video. And then we have a side that's going to not touch theta, which is going to be opposite. Okay, so we have an adjacent side, which touches theta. We have an opposite side, which does not touch theta. And then we have the hypotenuse, which is always the longest side. And in a right triangle, it's easy to identify the hypotenuse because the hypotenuse is always the side that does not touch the right angle. Okay, so if you're ever confused as to which one's the opposite or the adjacent or the hypotenuse, the first thing I would do is start by looking at the right angle and looking at the angle that is going to be opposite to get our hypotenuse. Now, if we can go through and define our function, okay, or if we can define our hypotenuse, our opposite, and our adjacent side, then here are the trigonometric definitions. The sine function is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the hypotenuse. Once we have those, then what we can do is we can just flip all of those over, because once we flip them over, that's going to give us the reciprocal functions. Okay, you might remember in the previous video, we defined cosecant to be the reciprocal of sine, secant to be the reciprocal of cosine, and tangent to be the reciprocal of cotangent, excuse me. All right, now, a way to memorize this relationship, okay, is take a look at the first letters. So we have SOH. So there's this saying, or I guess this phrase or imaginary word, so, ka, and then toa. Right? And maybe a way, this is what I read in one of the textbooks, a way to remember this is they have a saying that some old hog came around here and took our apples. All right, so if you ever forget Sokotoa, maybe just have this vision in your head of some old hog that came around here and took our apples. All right, and what that can do is that can tell you, if you look at the first letter in each of those, so, ka, and then omit the word and then toa. All right, so that might be a way for you to remember like the first letters. And then, of course, once you get those, then what you can do is you can just take the reciprocal. Okay, so again, sine opposite of over hypotenuse, some old hog. Ka, C-A-H, cosine is adjacent over hypotenuse, came around here. And then finally, tangent, took our apples. Tangent is opposite over adjacent. So a typical problem that you'll probably see in your exercises as well as on an examination is you're given a triangle and you have to find the 6 trigonometric functions of the given angle, okay? And of course, you want to try to rationalize. And so the first thing we want to do is let's define what the opposite, adjacent, and hypotenuse are. First thing, we notice that opposite of the right triangle is going to be, or the right angle, excuse me, is going to be 17. So our hypotenuse in this example is 17. Right? We know that if we look at the side that's going to, if we look at the angle, then what we have is we have the side that is not touching the angle. Okay, so the opposite is going to be 8. Now the question is, what is going to be the last side, the adjacent? Okay, and I'm going to call that A. All right, and we don't know what A is, but we do have a Pythagorean theorem. Okay, so if you're ever missing one of the sides of a right triangle, Okay, it has to be a right triangle. You can use your Pythagorean theorem, a squared plus b squared equals c squared. In this case, a squared, b squared is going to be 8 squared. All right, so a and b are going to be legs, and c is going to be the hypotenuse, which in this case is 17. Now, that means that a squared plus 64 is going to be equal to 289. And then if I subtract that from both sides, a squared is going to be 225. And then I can take the square root of both sides. And technically, a should be equal to plus or minus 15 by our square root principle. But we're only going to be dealing with positive lengths here. Okay, so we can ignore the negative. So a is going to be 15 for us. All right. Now that we know this, we can get our sine function. So the sine of theta, which is the opposite over hypotenuse, so is going to be equal to 8 over 17. And then ca, the cosine of theta, so ca is adjacent over hypotenuse, right? And the adjacent is going to be 15, the hypotenuse is 17. And then toa, the tangent of theta, is going to be opposite over hypotenuse. The opposite is going to be, I'm sorry, opposite over adjacent, excuse me. That's going to be equal to 8 over 15. Now, once we have those three, then what we can do is just take the reciprocal. Okay, so for instance, the cosecant of theta is going to be the reciprocal hypotenuse over opposite of sine, which is 17/8. And then we have the secant of theta, which is going to be the reciprocal of cosine, which is the hypotenuse over the adjacent. And so that's going to be 17/15. And then finally, the cotangent of theta is going to be the adjacent over the opposite, which is 15/8. All right, so these are going to be our 6 trigonometric functions of that right triangle. A secondary example, we have this angle x, and we have 1 and 6. All right, now we don't know the hypotenuse. Okay, so I'm going to call that c, all right, because that's opposite. But we do know that the adjacent side, which I'm going to call a, is equal to 1. And we have the opposite side, which I'm going to call b, okay, or the opposite. Okay, but I'm just going to use our Pythagorean theorem to be able to find b. Okay, so this is going to be our adjacent, and this is going to be our opposite. Right? Now to find c, 1 square plus 6 square equals c square. This would be 1 plus 36 equals c square. 37 equals c square, or root 37 equals c. Okay, so our square root of 37 is going to be our hypotenuse. Okay, so we don't always get really nice numbers. Sometimes we get these numbers that are irrational. Right. So now let's go ahead and start finding our sine, cosine, and tangent. For the sine of theta, now remember, sine is going to be opposite over hypotenuse. Okay, so that's going to be 6 over the square root of 37. Now, unfortunately, that's not rationalized. Excuse me. So what we're going to do is, remember, to rationalize a number, we're going to multiply. We're going to say root 37 over root 37. And so the rationalized version of this is going to be equal to 6 roots of 37 over 37. All right, so that's our sine function. All right, and also let's hold on to this because that's going to help us when we go to find the cosecant. Okay, in fact, what we can do is right away we can find the cosecant of theta by finding the reciprocal of this value, which would be root 37 over 6. All right, and that makes it a lot easier because then we don't have to rationalize that number. All right, so sometimes it's helpful to take the initial value as opposed to this number right here, and take the reciprocal of this. That might be a little bit uglier for us to try to rationalize. The cos of theta. Now remember, cosine is the adjacent over the hypotenuse. So the adjacent is 1, and the hypotenuse is root 37. And we're going to do the exact same thing where we have to rationalize. Right? So we're going to multiply by root 37 over root 37. Oh, not sure how that 3 got out there. All right, so we squeeze that back under. And so that's going to be equal to our square root of 37 divided by 37. And once again, what we can do is we can just take this value, and that's going to help us to find the secant of theta. All right, and secant of theta is going to be root 37 over 1, or just root 37. All right. Finally, tangent of theta. Remember, tangent, okay, so took our apples. All right, so that's going to be opposite over adjacent. And so that's going to be 6 over 1, or some people call that 6. Right? Now, the reciprocal of 6 is going to be the cotangent of theta, and the reciprocal of 6 is going to be 1/6. Okay, so that's how we can go ahead and use right triangles to be able to find our trigonometric values. Okay, so remember, try to memorize this SOHCAHTOA, and maybe this some old hog came around here and took our apples, and that might help you to remember all the relationships between the trigonometric functions and the right triangle. All right. Again, this is something that's going to be fundamental to our course. Okay, so the sooner you can have this memorized, the higher the likelihood it is that you're going to be able to do really well with these types of problems.